I'm going to record all of this, and I'm streaming it live to YouTube right now is actually what I'm doing. It's an extra little step for me, but it's going to make it much clearer for you to be able to see it because it does a really good job. It streams in 1080p. Once that is set up and I have like channels starting to go, I'll put a link so you can easily get to that channel and watch them if you want off of YouTube. All right. So bring up VMware Workstation Pro. And it should be VMware 14 is what it should be here. There we go. Now, can somebody tell me what virtualization is? What you got, Eric?
So it's kind of like a software that goes on top of the hardware that basically kind of allows you to emulate.
Strike the word emulate. You were doing really good up to that point.
That allows you to run other operating systems on top of the hardware.
Absolutely.
Keeping the primary operating system.
And we can even eliminate that. In a hypervisor 1 situation, there is no middleman like we have here. There's no middle operating system. It's what we call bare metal hypervisors. All right? So these are generally considered hypervisors. All right? You have Hyper-V, that's Microsoft's product. All right? You have VMware, and you also have another one called Zen. And they're all referred to as hypervisors. All right? An emulator, has anybody ever played with an actual emulator before? What emulator have you used?
It was like for Game Boy.
There you go. There's emulators for Game Boys. Anybody ever play with the Commodore 64 emulator? The Super NES emulator, the NES emulator. There's a PlayStation emulator called Bleem. When you hear emulator, think of hardware that is actually software. So they take software and they emulate what the hardware was. That means the hardware that's actually running is so powerful it can actually emulate the hardware that it once was. All right? Virtualization with these hypervisors, the hardware gives multiple operating systems access at the hardware level of things. All right? This gives us a very high response rate. The hypervisor machines, the guest machines inside, they're going to run at about 99%, maybe even higher than that, the speed that they would as if they were installed natively on bare metal. All right? As a result, multiple things happen. Now, instead of having a physical computer for every website, we can have multiple websites on one computer. By the way, Apache was the first to actually do that, enable multiple. But take it beyond that. What if we have a machine that typically sits idle 23 hours a day? It means 23 hours a day we have it turned on, but it's doing nothing but sitting there. What if I can sell that? What if I can sell those CPU resources, that RAM? What if we can start sharing it? And that's where virtualization came into, and now it's kind of like cloud computing. Cloud computing is built on all of this. So one physical server might have 15, 20 virtual instances of a guest. All right? And in this classroom, we're going to be able to set up with ease 5 or 10 guests inside of our host machine without any problems. Now, what else does this cut down on besides physical maintenance on these machines? Imagine if you have 20 physical machines or 100 physical machines, all the maintenance that has to happen on those. Fans go bad, memory goes bad, CPUs go bad, hard drives go bad, all that has to be fixed, right? So now I condense all 100 of those into maybe 5 machines, all right? Reduce my maintenance as far as a person goes, reliability. But I've also, if I go from 100 machines to 5 machines, machine's number one enemy is heat. I don't have to pump as much air conditioning in to get that air, that hot air out now. Right? My electrical consumption goes way down. 100 computers, 5 computers. Come on, that's pure logic. Right? And then VMware, the bigger of this, which is vSphere, that's the controller, and ESXi. That's the enterprise level virtualization solution from VMware. All right? It is very intelligent. Those 5 machines that we have up in Lowndes, we'll take a trip up to Lowndes. We have 5 virtualized physical machines. ESXi is on the back end of that. If you have a physical problem with one of the machines, ESXi, that's just the name of the product. It's called ESXi. You say, I have to fix something on machine 2. It says, okay, give me 5 minutes. Takes all the resources that are on that machine number 2, redistributes them to number 1, 3, 4, and 5, turns off the machine, sends you a notification, go do whatever maintenance you need to do. You go over and you do the maintenance you need to do, power it back on, and you're done. As soon as it comes back on, ESXi says, I've noticed that it's back. Can I migrate everything back over? You click yes, and away it goes. All the machines that are on 1, 3, 4, and 5 go back on 2, and you're back to 100%. So if you ever think about uptime, we measure uptime in % of a year. If you go to a company and they say, we guarantee uptime at 99%, that means you're looking at a couple of hours out of the year that they may be down. Those 9s make a difference. 99.99 means about 15 minutes out of the year they're down. And that's it. And that's where it all comes from, and that's how they can do it. Before all this came along, nobody guaranteed that stuff. Nobody made those guarantees. Question, Michael?
Now, when you're doing an active migration like that,
yep.
Can everyone still use those resources as it's being migrated? Or are they
it's completely transparent to the end user. Okay. And 100%, because you got to remember, we're moving from a little desktop unit here to the enterprise. All those servers that I'm talking about up there, none of them have hard drives in them. None of them have hard drives. So now, if you take a step back and you're like, well, gee, if there's no hard drives, that means all I have to do is dynamically tell wherever the hard drives are that now the machine is on this machine, and that's exactly what it does. It repoints it. It says, oh, now it's located on this machine. Completely migrated from one machine to the other, completely transparent to the end user. You have no idea. There might be a slight slowdown as things are shifted, but only a really astute person that maybe uses it a lot would actually notice it. For the most part, nobody ever notices it. How many people play like Xbox and those different services? This is what it's built on. Microsoft built their Azure cloud based on what they learned out of their cloud services for Xbox. That's where they gained a lot of their knowledge to build Azure. That's Amazon's cloud services. All right? So as we move forward, one of the things that needs to go on your resume in addition to this class is your ability to understand conceptually what's going on with virtualization technology, with cloud technology. And this is one of the disconnects. A lot of students get to the end and they're like, well, I don't know what I learned. Well, I'm telling you right now, in your notes for your portfolio, you need to write VMware 14, virtualization concepts, learned, learning it now. All right? So, this is what we're going to do. Very first thing on these machines, we need to make a change. So come up to File, and, or is it Edit? I'm sorry, go to Edit and go to Preferences. And what I need you to do is that you need to change your workspace from, yours probably says FSU NAS 1 something blah blah blah. You need to click on Browse, and you need to change it to the solid state drive. And when you get there, make a new folder called your username. I want to make mine M. Flynn. So everybody in here, do not click OK. I want to come around and validate that you've done that and you understand what's going on. You're going to change your workspace on these machines to the solid state drive, the SSD. All right? You need to make a new folder called your username. It's Edit Preferences. And you'll see it. It's the first one. Is everybody logged in? Everybody's logged in? I'll cast my screen up there. You're not logged in yet? As soon as you're logged in, I'll cast my screen up because I know that's a little hard to see sometimes. Yes, because this is a shared drive, so you need to make a new folder with your username, right? And that's where you're going to now store all of your virtual machines. It's going to go in there, all right? Now, on your home machine, you don't need to do this, all right? You just don't have write permissions anywhere else on these machines, and if you try to store it to your H drive, they're going to call me and they're going to be like, somebody's trying to fill up the H drive again. I'm like, well, buy a bigger SAN. Absolutely. So yeah, Michael makes a good point. Maybe on Friday I'll bring in an SSD and a mechanical drive. If you have me for 101, you've seen a mechanical drive, and you can see why they're so slow. It's things spinning on the inside and arms moving back and forth. That's what makes them so slow. They're mechanical. A solid state is kind of like your flash drive. Who has a flash drive in here? So you got a flash drive with you. It's like that, except for it has the best flash memory and it has a special controller. So it has multiple chips and it has a special controller that allows data to be read and written to multiple chips at the same time. And what happens is they're like 10 times faster, and they get even faster when we're talking about high input-output. All right? Because with a mechanical drive, it has to go all over the place. Chips, same access time anywhere on any of those chips. All right? So if you have access to a solid state, or buy one, Michael's right, buy one and hook it up to your USB 3. It'll still be faster. It's for sale for $500. Not for $500, only 128 gig. There you go. I'll part with it for 50. 50, that's a good deal. It'll come with a SATA. There you go. Okay, did everybody get that? Yep. Let me get around and double check. Yep. No, I didn't. It okay. Yep. 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 Yes. Yes. Getting him there? SSD, make new folder. Scoot in. Yes. Did I get you too?
The CSIT fixed or whatever?
It's okay. I put it down there for you. This machine, the group policies aren't coming out for whatever reason. So you have Windows 7, so you'll be okay for now. And I'll get the rest of it taken care of. But you can click OK there. Yes. Okay. So what we've done now is this solid state drive, we've given ourselves permission on the solid state drive, and we've given ourselves a folder. That's where all of our machines, all of our guests are going to reside. Every guest that we create is going to reside there. So now I want to say, create new virtual machine. And I'm going to do custom. I'm not going to do typical. What's up? You must have not created that directory, right? You got to create that directory. Hit OK. Hit Okay, hit browse. Find the SSD. Now click on make new folder. There you go. Right? Okay. VMware will actually automate the entire installation process. Because as exciting as this is going to be for you, the first 2 or 3 or 10 times you do it, after about the 20th or 30th time, it becomes pretty mundane, and you just wish it would be automated. And it will. It'll automate it for you. All right? But right now, I want to go through the custom so you can look at the different things. Let me cast my screen out to everybody here. Everybody can see me? Okay, so I want to click on custom. I'm going to click on next. It's going to ask me, what do I want? Hardware version 14. That's what we are here. Okay? It starts talking about the different limitations that it might have. For example, Workstation, this is a logical block on how much memory you can stick into a machine. Okay? That is Workstation. VMware is doing that. In ESXi, that Enterprise Edition that costs tens of thousands of dollars, if you have a terabyte of RAM, which is not unheard of, you could actually stick 500 gigabytes of RAM into a guest machine if you wanted. So this all comes down to basic limitations so you understand what you're in for. All right? 10 network adapters max. That's actually up from 12. 12 you can only put 4 in. Here you can put 10 in. So you can actually simulate a switch with this thing if you wanted to. All right? So we'll click on next. Kind of tells us the basics. It's going to ask us where the disk installer is. Now remember, in ISO, ISO stands for International Standards Organization. People refer to this as an ISO. It is an image, a snapshot of an actual DVD. All right? So that's what I had you download off of the CSIT fixed and bring it down. We're going to insert that into the DVD reader inside of our guest machine. So we're going to go out to that installer, look for that ISO image, and it's out on our D drive. There's the Windows 7. All right? That's going to be my installer disk. Notice how it automatically detected what it was. Then I'm going to click, oh, by the way, if you want to try playing with OS X, you can do it, but you got to borrow an image from somewhere else, and I'll leave it at that. There's some little things you got to do. It won't just automatically install on a Windows machine, is what it is. So that's what we drug down. It's on the SSD drive. Now I want to click on next, and it's going to ask for a Windows product. We can actually select professional here and leave that blank. Now it's going to ask, well, what do you want in here? What's your name? You can put your name in there. What password do you want? I'm going to put a password in there. So here's another one for your notes. This is known as an answer key. What we're creating is an answer key. It'll automate the install of Windows. You can make these answer keys. You can actually put group policies in place. We're not going to really get to group policies in here, but you could put group policies in place by making your own answer key beforehand.
Where's the first file we have to
CCT fixed, ISOs, Windows, Windows 7, and down. There you go.
Okay.
Oh, it's already there.
Oh, okay.
So skip this file. And now you need to come back out to that right there. There you go. No, that's not what I want.
Oh, it was that one.
Yeah, you want it off of that one. It'll be much faster. All right. So, by the way, in this class, and I really probably shouldn't do this because I don't want you to get in the habit of it, but I use the password as password !@ with a capital P. Why do I do that? Because you're going to lock yourself out of your computer otherwise. So use a weak but strong enough password in here as we're learning. As you become a professional, every single thing you do even in non-production stuff, should have a strong password. So it doesn't accidentally roll out like Apple did recently with a password of admin. True story. Over January, they did that.
I'm even lazier when it comes to my VMs. Just 100 password.
Yep. Yep. Okay, so then I'm going to click on Next. And I want to say, yes, it's okay. Now it's going to ask, what do I want to do? I'm going to call this Windows 7 Base. And you'll find out why I want to call it Base. And I want to call it Base. And I'm going to click on Next. All right, firmware type, BIOS or UEFI. BIOS is going the way of the dinosaur, stands for Basic Input Output System. UEFI stands for Universal, can't remember the other three. All right, but it's much better than BIOS. It's much bigger. BIOS is a dinosaur, literally. It's like 40 or 50 years old. All right. We got to stick with that. Now here we have the ability to determine how many processors we want in here. So now the decision you make here is how much of my host resources do I want to leverage in my guest? All right? These are quad-core machines with 32 gigs of RAM. All right? VMware will do a very good job of balancing, like if you put 4 cores in each one of them, it'll do a pretty good job of balancing between all of your guest machines saying they have 4 cores in it, right? But it's a conscious effort that you need to make as you set up these virtualized environments. Darnell? BIOS, regular BIOS. Yep. So I'm going to stick with one processor. I'm going to put 2 cores in just because it's a little bit faster. That means that it will use 2 of my physical cores when they're available. All right. Next decision is how much RAM I want to put in here. I have a maximum of 32 gigs of RAM. It says 27.9, but that's because the host operating system, because it's an actual operating system, needs some memory. So it's going to say, well, if we go allow you to put anything more than 27.9 in, you might lock up your host. That's kind of a bad thing, right? I'm going to put 4 into mine because we can, and that's what having 32 gigs available for us, it makes them very fast. Between the SSD and having a lot of memory, we can start up a whole bunch of guests, all right? So I want to put 4096, that's 4 gigs in there. Notice how it bumps up. There's a slider, but I'll put 4096. Now, the next thing, and I'll show you this, is it's going to ask, I have some graphics on this as we begin to install everything. Use bridge node, use NAT, use host only, do not use a network connector. I want you to use bridged right now. And I'm not going to go over why. I want us to get started, and then I'll show you some slides that you can take some notes on, okay? So we're going to use bridged networking. Then I want to click on Next. Now, here it's going to say, what kind of SCSI controller do you want? We can go with the LSI Logic SAS recommended. All right? SAS actually stands for Serially Attached SCSI. SAS. Serially Attached SCSI. I see so many people writing that down. Clearly, it was worth my breath. Now it's going to ask what kind of virtual type do you want? Do you want SCSI or IDE? We'll go with SCSI on this. Now it asks, do you want to create a new virtual disk, use an existing, or use a physical? We can actually attach to a physical disk if we want, which is very nice in an enterprise setting. We're just going to use a virtual. It's going to ask how big we want it to be. 60 gigs is fine, and notice that allocate all disk space now is unchecked. If we were to check that and we ran this, 60 gigs off of your solid state is going to poof, disappear. It's going to be used up in that. If we do it without it, what it does is it dynamically expands as we install more things on it. All right? That way we can go up to 60 gigs, but if I only have 15 gigs used, I'm only using 15 gigs of my physical space. Everybody with me on that? Understanding? Now the other thing is, store virtual disk as a single file or split it into multiple files. All right? It says splitting it into multiple files makes it easier to move to another computer. The reason it's easier to move to another computer is because of file size limitations on flash drives, all right, or on an external drive. When you don't know what you're talking about, you can go with that. If you know that NTFS will accommodate larger file sizes, and that's what your flash drive is formatted as instead of FAT32, you can go with stored as one. If you don't know what I'm talking about, you write down in your notes right now, what's the difference between FAT32 and NTFS? And you go out and you take 5 minutes to learn what the difference is, because that's a very important thing to know. NTFS and FAT32. And you can even put XFAT, EXFAT. FAT stands for File Allocation Table. Stores a single file. All right. So this is the file extension for my hard drive. All right. Remember, it's a virtual hard drive. Notice it's a VMDK, virtual machine disk. I don't know what the K is. Maybe it's this DK disk, right? It's a universal format. So theoretically, we could take it from here and go to Zen or go to Hyper-V or whatever, and it's easily converted. All right. But if you're going to transfer your file, that's what you would be looking for. Transfer your machine, take it home. Click on Next. All right. I'm going to go to the next, and I'm going to click on Customize Hardware just so you can see all the neat things we can play with in here. We're not going to change anything, but you can there's where you can adjust your processors. You can add more memory in. You can add an additional hard drive or a CD DVD drive in. You can connect to your host DVD drive. See, there's actually a DVD drive on there. We can actually connect to that and load things off of the physical into our guest. Remember, we can install multiple network adapters. We can install up to 10 network adapters. I'll go over what bridge, NAT, host only, so on and so forth is here and again in a minute. We have USB compatibility. USB 3 was flaky inside of virtual machines. I don't know if it's any better or not. I always kind of lean towards going to the older ones unless you really need to load something in at a faster speed. All right. You can install different sound cards. You can put printers on, and you can even do multiple displays. All right. And then you can add other hardware in. For example, you can add a parallel port, a serial port, another SCSI device, a trusted platform module. That is a module that goes in to make your network trust a specific device. All right? When we get to the enterprise level with secure computing and whatnot, we start talking about that. And there's that add another network adapter. I'm going to hit cancel there. And then I'm going to hit close here. And then I'm going to click on finish here, and it's going to say power on this virtual machine after creation. And what's going to happen is after it creates the disk, it's going to start installing completely automated Windows 7 for you. All right, a lot of information coming at you. Take a breather. See if you have any questions in your notes. Hit no. What happened?
I didn't click anything. I didn't know what I was doing.
Yes, just close. It actually stands for, okay, what'd you do? let's just delete this. I'm not sure what happened. We'll remove it, and then we'll add it back in, and I'll walk you through pretty quick here.
I don't remember what I saw myself. I got so used to it. Oh, yeah.
Does it matter for the running password?
Nah, you can do that later. It's called that base. Next. Hit OK. Hit, base, type base 1 or something. That's fine. Mm-hmm. Mm-hmm.
Yeah.
Do bridged. Mm-hmm. Okay. Okay.
Single file?
Yep. Mm-hmm. Yep. Okay. Is that better now?
I mean, that's the same thing I just had, but
Did it do that last time?
after this came up.
This is when it popped up and said something weird. That's weird. Let me see.
That's weird.
No. See if I get you by for now. I'll see what's up with that later. Okay, so let's take some notes while we're waiting on that to set up. All right, let's take some basic notes here. So inside of the course under Files, I put some VMware help files, and there's 3 different ways in which we could have connected a few minutes ago. There was bridged, there's NAT with DHCP, and internal network only. All right, I need you to draw these into your notes and think about it. So this is a bridged network. So when we do a bridged network, it's like taking a Cat5 cord, okay, and plugging it into your guest machine inside of your host. All right? So plugging it into there and then plugging it into a wall jack or a floor jack into Frostburg's network. That's bridged. All right? So we can see here, host to NIC bridged. So the host network, we're going to connect straight into our host network switch. All right? And that's when we're setting it up here as bridged. Now what's going to happen is when we check what our IP address is, we're going to get a DHCP address from Frostburg. It's going to be as if this particular guest is connected to Frostburg's network infrastructure. All right? So there's no difference to the host. That's bridged. All right? That's bridged. The other one is NAT. The other type of connection is NAT. So in this format, my guest and my host could easily communicate back and forth. Right? It'd be real easy actually for any of your guests to communicate with anybody else's guests as long as we're all bridged. It's like we're all connected to the same physical switch. Okay, that's internal only. Let me go to the next one. Here is NAT with DHCP. If we're going to do NAT with, okay, NAT stands for Network Address Translation. That's what happens at home when you come from the internet into your house. Your firewall actually does a NAT, okay, Network Address Translation. At that point in time, if you're setting your stuff up as a NAT connection, the DHCP, the IP address, is actually going to come from VirtualBox or from VMware in this case. So at that point, your guest isn't going to be able to directly communicate with your host machine. All right? I know that sounds bizarre, but it's behind a little firewall. It's the most basic type of firewall we have, called network address translation. That used to be the only types of firewalls we had, was NAT firewalls. So the IP address that I receive, I'm still going to get one from the DHCP server, Dynamic Host Configuration Protocol server, still going to get one, but it's going to be coming from VMware for my machine. All right? Is everybody okay so far? All right. The last type of connection that you were allowed to make when we set this up, and by the way, you can change this anytime you want, is internal network only. Okay? When we choose the internal network only, we're not connecting to anything else. We're not connecting to Frostburg's network. We're not connecting to our internal VMware network. We don't have access to a DHCP server, a DNS server, none of that stuff. So your machine, your guest machine, it won't even have an IP address other than the 169 address. The 169 address is a special set of addresses that tells you your connection is actually working, but I don't have an address from anything. Anytime you see an IP address of 169, that's a clue that TCP IP is working, but I'm not getting an actual address from anywhere. Okay? That's what a lot of people think the 169 is something weird. Right? They're like, oh my God, this is some random IP address. It's actually not. It's an indicator that your TCP IP stack is working and functioning appropriately. You're just not receiving an IP address from anywhere. So when we go to internal network only like this, we are going to be using and setting static IP addresses if we want things to communicate. Now, if we have everything on the same switch like this, because that's what you need to think of, is we're plugging things into a switch. A switch called internal network where only the guest on my host can communicate. A switch called bridged, which actually is out to Frostburg. A switch called NAT, and we'll get more specific, like work group 1, work group 2, whatever. They're all connecting and they can communicate with one another. All right? So if we go back to our, if we go back here, we should see that we now have our machine. Mine is ready to go anyways. Now, when you install your own operating system on your own computer, the last thing you have to do is install your drivers. Your drivers are the piece of software that enable the operating system to communicate with the hardware underneath. In VMware, for the basic VMware, you need to install, if it hasn't done it already, you need to install VMware Tools. Now, mine's already installed VMware Tools, and one of the things I'm going to do is I'm going to ask it to reboot. And notice how fast it reboots. I mean, it's going to be pretty fast as it reboots. Yes. Reboot, restart. Yeah, it says mine are installed, but I don't see where it is. Yep, there it is. All right.
So if it says install, we don't have it yet?
If it says install, you don't have it on there yet. It should automatically install it. Now, one of the things you can do is you can go into full screen mode, But one of the things you need to be aware of is the reason I called this base is we can actually make clones of this thing. All right? We can also take snapshots. So I want to take a snapshot of my machine right now, and I want to call this clean install. One of the other things I want to do is I'm going to come in and I'm going to turn off the automatic updates so that my machine doesn't start rebooting and everything else that it's going to do. All right, so mine are automatically turned off right now. All right. What's that? I hit the Windows key and then I type in Windows Update. That is your shortcut. Try to get away from that mouse as best as you can. All right. Now let's play with that snapshot thing for just a minute. Watch what I do. I'm going to go out and I want to download Google Chrome real quick. Actually, I want to show you something really cool. Has anybody ever heard of Nanite?
Yeah.
All right. So check out Nanite. I want to go out to Nanite here. And this thing will make a package for you to install a whole bunch of different things. So I could go down through and install all these different pieces of software if I wanted. I'm just going to get one. And now it's going to download and it's going to run everything for me. You good? Okay. So go up to your VMware and come down to hold on. Oh, I'm sorry. There we go. Click on VM and click on Settings. And in Settings under Network Adapter, make sure it says Bridged. Does it say Bridged? And you don't have a connection to the network?
He's getting the same problem over here too. He's not being able to get an internet connection.
I don't have an internet connection either.
I don't either.
Do you have an internet connection?
I do. He does.
I'm good.
It's weird. Some people do. He has it.
That's okay. We'll play with it in a minute. I want to show you this real quick because we're almost done. I'll figure that out. So let's say that I've decided that I screwed up. I took a snapshot. If I come in here and I right click and I say manage, hold on, snapshots, snapshot manager, and I say go back to here, watch what happens. All within about, what, 30 seconds? So what I want you to think about is I just installed Chrome and Firefox. It's gone. You want to use Snapshot. That is a big feature of this. Before you start doing any of the labs, and before you start doing this and doing that, and as you move through the labs, you want to take snapshots. So that when you do screw up, because each and every one of you are going to mess something up, you don't have to do a complete reinstall of everything and start the lab all the way over. You can just go back to where you know that it worked fine and keep on moving. All right? That's a really nice feature. Could you imagine that? Like, they're trying to do that with machines now. Like Apple OS X actually has that built in. You can say, I want to go back to this, it's called Time Machine. I want to go back to this place in time. And boom, you're there. Right? Can you imagine if all machines were that way? Oh man, I was surfing the web and I accidentally got attacked by something. Go back in time to here before I surf that. Poof, fixed. Everything, just like that, instantly. Let me go back in time just a minute. Now, Windows has tried to implement that, but the file system, it's a problem with the file system. Here, all we're doing is, it's just a bit comparison. It's actually saving the state of it, and it can just go back.
The Windows kernel is really big, so I can see how you not have problems trying to implement that size.
It actually comes down to the file system.
Oh, really?
Yep, it's the file system can't handle that type of a request. So
Would it be a push to switch over to a file system that can?
they're trying. They're in process. Yep.
So how did you do when you went back? So if you go to Snapshot Manager, you just click.
If you go to Snapshot Manager, you can go back to wherever you wanted to go.
So like I could click on Clean Install and then.
And it'll take you right back to there. Now it's going to delete everything before that. But see, what you could do is you could take a clone of where you are. So that's where it. I didn't want to go into that too much. But let's say that you moved out so far and you're not sure if you've screwed up, but you want to see if you did. You could take a clone of where you are, right? Go back to where you were. Oh no, that's wrong. Go back to your clone that you made and keep on going.
So basically, you're right now where we all are. Like we don't have the.
Yep.
Anything installed.
Yep. Except for you don't have internet connection either, which is a problem for me. All right, so we got to where I really wanted to be today. All right. What I would like for you to do is make sure you're here on time. Showing up early is on time because we need to be logged into these machines. We're going to download some other stuff and get rolling with more of an introduction to setting things up, having multiple instances, maybe get a little bit of basic communication going on, continuing to talk about networking, and we're going to keep on moving forward, okay? You do have internet connection? Yeah, that's why I wanted. It's not a representation, it's a real desktop. That's a real machine.
On top of your current hardware.
Yep. As far as it's concerned, it is its own. And that's the hardest thing to wrap around the first time you're introduced to this is, but it's not really a machine. No, it really is. It thinks that it is all by itself in its own safe little black box.
There's very few ways for it to be able to tell the difference. One is a string of code called red pill, blue pill.
This isn't an emulator.
Whether or not it is a virtual machine. But aside from that,
A game? No, these are not designed for games. Right? Keep that in mind. VMware is not designed for games. Now, Parallels from Macs does a pretty good job of doing some game emulation because actually the GPUs have a lot of tie-ins, but VMware does not focus on games because this isn't about it.
one VMware,
Yep.
you run into a whole bunch of lag times between cycles.
What it comes down to is actually tying to the GPU. VMware just doesn't focus on it. So.
If I want it on my Mac, what should I?
Fusion 10. Fusion 10.
Is this something that we should download on our computer?
Absolutely. You should start playing with it. Okay?